Welcome to this is for magic, where learning things gets magical. Let's do question 18. Question 18. A steel ball of mass 73 grams, so M equal to 73 grams, is held 1.6 meters, above a horizontal plate. During a straight diagram, the ball is dropped from rest, so U is equal to 0 meters per second, and it bounces on the plate reaching a high pitch. So when it hits here, it will bounce up again until it reaches high pitch. So this is the rebound height. To make things easy, I'm going to draw a dotted line showing that it's going like this. After that, it bounces back up. Okay. I have to move it apart, although it will bounce back here so that you can see actually what's happening. Okay. So this is not drawn according to how the experiment actually works. Then, A. Calculate the speed of the ball as it reaches the plate. So we'll define V here. Again, use your UV Saturday line, so draw your line since you're moving downwards, is positive. U, V, Saturday, U, 0, V, we need, as we got 1.6 meters, we need one more number, which is plus G. We don't need this. Which one has US and V? Will be a fifth equation. V squared is equal to U squared plus 2S. U here is equal to 0. So, V is equal to 2 times 9.81 times 1.6. Square root the whole thing. Hopefully when I pause the video, you should get a value of around 5.6 meters per second. Okay. Once you do the UV Saturday lines enough, once you go to the topics, you realize it's actually quite easy. This is a fine technique we learned before. Next one, B. As the ball loses contact with the plate after bouncing, the kinetic energy of the ball is 90% of that just before bouncing. So EK mu is equal to 90% of EKO, which is just equal to 90%. A number 0.90 times half mv squared. Here is half mu squared. Okay. And let's see whether that makes sense. And actually, in fact, it doesn't make sense because this one is about rebound. Your old EK, which is half mv squared here, and your rebound, which is, let's call it V rebound. Why? At maximum height, your V rebound at max height will be equal to 0. So that means this kinetic energy, which is your EKO, this is your EKO, and this one will be your EK mu. So we can't use U and V because we just confused you here. It's actually VR and V. So V is here and VR is here. So let's see what else information do we have. Calculate 1. The height pitch to which the ball bounces. Suddenly, there's one height. This height here. But we're dealing with EK, and you already know what we're going to use. So, using principle of conservation of total energy, sum of your energy source is equal to sum of your energy use. In this case, it's mentioned that your source of energy is your original velocity in which you hit the object, hit at the bottom, which is this guy here, plus half mv squared. The use here is to gain mgh here, okay, to get a height. But we have a problem. It says 90%. The new EK to go all the way up is 90% of EKO. So what does that mean? it means that once you reach the stage, you say, oh, wait a minute, we're going to use the energy to move up, but in gravitational potential energy, mgh. But there will be energy loss. How much is lost? Here you have 90%. This is this part here. Your kinetic energy converted into gravitational potential energy, and the energy loss you're going to lose 10%. Could be thermal energy, could be sound energy, could be anything. Okay, but we just need this information here. So, what is mgh? Like the previous video, mgh is 90% of the original energy. Change the number 0.90 times half mv squared. The n cancel out each other. So you got h is equal to 0.90 times half. Your v here we measured to be 5.6 meters per second. Squared divided by 9.81. So hopefully once you calculate this and unpause the video, you should have a value of around 1.44 meters. Hopefully get that value. Now moving on to the next component, we got the speed of the ball and release the plate after bouncing. So what is VR equal to? We can do the same thing. Instead of using half mv squared is equal to mgh, we can instead convert this back into energy. So therefore, you got half mv squared is equal to half mvr squared plus energy loss here. Again, this is 10% because this one is 90% of the original one, and this is your 100%. So, half m vr squared, which is less, remember, energy used is always less, energy is also more, is equal to 90% of half mv squared. Your half cancel out each other, your n cancel out each other. So you're gonna have, we continue 2 here, or maybe we just continue 2 here. So VR is equal to 0.90 times V, which is 5.6 squared, and then we square root the whole thing. So your VR in this case, once you unpause the video, you should get around 5.3 meters per second, which makes sense because you lose some energy, therefore your speed will not be the same. Now we go to the next part. Using your answers in A and B, determine the change of momentum of the ball during the bounce. B wants change in momentum. What is momentum? Momentum is delta P, which is m delta V. In this case, it's m V minus u. We choose our direction because velocity is vector. We choose our direction upwards to be positive. And our mass is given here. So it's 73 times 10 to the minus 3, change it to SI base units. V upwards, we have measured, in this case, during the rebound, is 5.3. So it's positive 5.3 minus U here is going downwards, V downwards, which is 5.6. So it's going downwards, it's minus 5.6. And you see, if you come to class, watch an unpause video, hopefully you get this number. You get 0.80 Newton second. Okay? Newton second, or if you want, you know M is kilograms, you know V is meters per second, you can just write this units instead. Okay, let's move to the next part, which is D. Oh, apologies, this is C, because D is already A, then D. With reference to the law of conservation of momentum, comment on the answer to C. So they want you to use POCOM, principle of conservation of momentum, and comment on C. What is principle of conservation of momentum? Where the total momentum in the system, the closed system is constant. What is a closed system here? Your closed system is the ball and plate. Basically, when you have a change in momentum, it means the force is applied. So when there is a ball hits the plate and rebounds, there's a force exerted onto the plate. What happens to the plate? The plate also exerts equal opposite force. Back to the third law. Okay. So, what's the answer? You just need to mention closed system is ball and plate. Therefore, plate must. What happens here? You lose momentum by the ball. That lost momentum is gained by the plate. Plate must gain momentum of 0.80 Newton second in downward direction. Okay. Not easy to understand why the word is it downwards. When the ball is going down, shouldn't the plate be going upwards? Quite easy. Look at the final rebound. Where is the ball going? The ball is going up. In order for the ball to go up, where must the force for change momentum be? The change momentum must be upwards. Hence, you look here, it's positive, so you can actually check the change momentum is actually upwards. But if you understand that, there's no action. That is the reason. So if this is upwards, therefore the momentum, change momentum on the plate must be downwards, as shown here. So I hope you understand this video. It's a bit long, it's a bit challenging, but as long as we bit by bit and follow the videos previously, you should be able to get it. So I hope you understand this video. If not, please replay this